This is another experiment. You see, this has a cap, a simple cap. If it is open or I put this cap, doesn't matter, because this is a tube open. So if I close it, doesn't matter. Only thing, I have another bottle which has a longer tube, but it is also open. Now let us see, if we pour water in this tube, what happens. Now obviously there is a tube below, the water will come out, therefore I pour water carefully on this. Now I am going to open this lower, and you see the water is coming with a large force and it is covering a large distance. But as the time goes on, this distance is decreasing. As the level is falling, this distance is decreasing. And at the end, it will almost come near this nozzle. So you see, now it is very slow. So initially the water comes up to this, now it is coming to this point only. Now let us see what happens to this bottle. Let me fill up this bottle also. Almost same condition, only the tube is longer. Let us put this tightly. Now I open this. Look carefully that the flow of water remains constant. It is not changing at all. Isn't it? Why it is not changing at all? You see, it is a constant flow. That means it is not changing its flow. Constantly it is giving the same amount of water per unit time. Then only difference is that doesn't have a longer tube, but this has a longer tube. What happened, actually air is coming out through this. That means instead of here, the air pressure is acting here. That means actually the difference of pressure for this height only. And this is a very interesting method, because in your tank, you know, when the tank is full, when you open your tap, you get water at a very large force. But if there are many people in that house, you expect that so that all of them should get equal amount of water. Then what we have to do, you just insert a tube almost to the exit, so that will keep the flow of water constant. This is also another experiment on air pressure and hydrostatics.